Now, the last thing I want to do in some of these reviews is I'm going to do a similar procedure here, but this uses not the tangent inverse form. This is the sine inverse form, because we know the sine inverse form, that's 1 over the square root of a squared. It's a constant squared minus a variable expression squared, and it's got to be inside of a square root. So in this case, a is 4 because we have 16 squared, and u is x. Right? So this is we're sniffing around the sine inverse form, but there are some differences, and that's one of the reasons I want to sort of point this out. Let me write this better so you can see it. It's not coming through on the video very well, I don't think, so I'm going to rewrite that. This is 2x over the square root 16 minus x squared dx. All right, so let's kind of go through. Well, we won't take it quite as much extensive as I did in the previous three. I'll leave these for you to work out the details. But here, number one, it should be clear. We can take this. This is a constant multiplier, so it can come out front of the integral. You may not bring a variable in front, right? Only a constant multiplier multiplies along. And then this becomes 1 over 16 minus x squared du. And then this is sine inverse form. Right? This is the sine inverse form where a is equal to 4 and u is equal to x and dx is equal to du, and you're off to the races. So number one should work out very straightforwardly if you know the sine inverse form. All right? Number two, notice this is degree 2, this is degree 1. So if we rewrite this, radical as 1/2 power and let u equal. One thing to bear in mind, very often when you're doing an ordinary u substitution, radicals should become 1/2 power. When you're doing an ordinary u substitution, radicals become 1/2 power. It makes things usually very easy, or a little easier. Let u equal the second degree. The derivative here is negative 2x dx. And I think this is not finished, but I think you can probably take that the rest of the way home from there. So you should be able to work that out. And then number three, now is it clear? We cannot do the same thing we did a while ago, because on the previous examples, what we did, these were both polynomials. Polynomial in numerator, polynomial in denominators. It was 8x second and x squared minus, or plus 16. These were polynomial. This denominator is not a polynomial anymore, so you cannot do that long division polynomial process. In fact, nothing you've talked about in Calc 1 equips you for this, because this requires trig substitution. This requires a trig substitution, which is something we'll talk about later in this chapter. Because this is the radical means you cannot do the polynomial division. And when that occurs, you're stuck using the trig substitution. So see if you can work this out, and then put this on the back burner, and then a few sections later on from now, we'll have that covered out, so you should be able to handle that. So that's the procedure. Try to work through those, and then I will have on the home page, I'll have a set of problems that you can practice. Make sure you practice everything on that assignment, that first assignment. Everything is going to be something you should be able to do from Calculus 1. Everything should be something you should do from Calculus 1. All the basic forms that you'll need are either on the forms that I have put together. I think they're on one of the pages in the text, at least the integral forms. The derivative forms are earlier in the text. But you need to learn your basic forms, and then practice the procedures to get the techniques of integration back up in your mind, so that as we go forward into Chapter 8, you're going to be in good stead.